We can also use Kirchhoffs laws to calculate the currents in each circuit. There's a three-step way to do it. You draw the loops, apply the laws, V1 plus V2 plus V3 equals 0, and then you can solve the equations. We can use our calculator to actually solve the equation for us. So you will set up three equations. You need to have an I1 and an I2 and an I3. I1 plus I2 plus I3 equals 0. Some of them might be plus, minus, not a problem. So if you have your three equations looking like this, you just need to press mode 5 and then 2, x, y, z equals n. I1, I2, I3 equals the number. Once you put the values in the table, you will get your answers. Let's try a couple of examples. This is similar to the first one I showed you, but I've added an extra battery in here just to spice things up a little. Let's figure this out. First things first, we need to know I1, I2, I3. So if I take any junction, I will pick a junction, maybe this one here, and I can see what's coming in. So we have I1 coming in, and I will have I2 coming out, and then we can take this battery, follow this loop, and we can guess perhaps I3 will come out. Maybe. I'm just guessing it because I am saying that the current from this loop will go in this direction, so perhaps it will come out. If I'm wrong, it's okay. I will get a negative answer. If I get a negative answer, it means I was wrong and the current is actually going this way. If my answer is positive, I guessed correct. No problem. So this is a zoomed in view here. I1 in, I2 and I3 out. So I1 equals I2 plus I3. I'll rearrange it like I showed you in the previous slide. I will have I1 and then I2 and I3 on the left hand side. So this becomes minus, this becomes minus. I1 minus I2 minus I3 equals 0. That's my x, my y, my z, 0. That's the first equation, done. We have one equation. We need two more to make sure that we can solve the simultaneous equation. So let's find two more. I can do another loop. I can pick a loop over here, and I can actually use this loop too. I can even use a big loop around the outside. Let's keep it simple. Let's start with this first loop over here, starting from this battery over here. I'll use KVL. I know this V1 plus V2 plus V3 should equal to 0. I have 30 volts minus IR minus 2 times I1 minus IR again. In this case, this is 5 ohms times I2. Remember, this is I1 and this is I2. So make sure you've separated them. So this is my next formula. I'll rearrange it a little. I'll take the i's to the other side. So I will have 30 equals 2i plus 5i. I can rewrite it a little bit differently if you want. I can just swap the two sides around. I can just write 2i1 plus 5i2. There is no i3, so I can just write 0 for the calculator if you like. I don't need to write it. Equals 30. X, Y, Z, there is no Z, so it's 0, equals 30. Equation 2, done. So we've done equation 1, we've done equation 2, and now you just need to quickly get the third equation. We will use the right-hand side. I can start from this battery over here. I can use loop 2. I have 10 volts coming from the battery. I am losing 3i3 over here, and I will, now, I did say I was going to lose through a resistor, but if you remember, when I did this, I should have written the plus and the minus. I dropped here, and I lost here, which means this was a plus and a minus. I have to keep the same notation. Now, even though I am going to lose here, the current, I have decided from my loop, is coming up. And if that's the case, with my right-hand loop, the current coming up, I am actually going from minus to plus. I'm not allowed to change this. I chose this to be a drop for this loop. I have to keep the same. So in this case, this will be plus 5i2, which is over here, 5i2. And then that equals to 0. So I've done I2. This is positive because I am technically gaining, which doesn't make sense, I know, but I have to keep the same annotations. I did plus to minus from the previous loop because I lost. So in this case, if I'm going in the opposite direction, it must be a gain. That way, you will get your answer correct in the calculator. Rearranging this a little, I'll take this to the other side, I'll take that, this becomes plus, this becomes minus. I have my next formula that looks like this. Again, I can rearrange it a little. I'll have the 10 on the other side. There is no I1, so I can just say 0 for I1, minus 5I2, and then Z, which is this one here, that's a positive, so plus 3I3, and that all equals to 10. This is equation number 3. We are done with the equations. We can go ahead and solve, and we can get our answers. If I was to go ahead and solve it, you will have your calculator. You'll press your mode, you'll press equation, you'll press 5, and you will get, you will press 2 after that. And you should hopefully get the equation with the table, x, y, z, and a number. X, y, z, and a number. In the first part of the table, what I will write is the first equation, I1, I'll write number 1 only, because 1I1, minus 1, and I'll write 0. Then I'll write the second equation, 2I1, 2, plus 5I2, 5, plus 0. There is no I3 in our equation over here, so I will just put 0 here. That's why I wrote the 0 for this part here. And then that number is 30. And looking at the second loop, I rearranged it to make it easier for myself. You can see that there is no I1 over here, so I will just write a 0 for I1. I do have an I2, which was minus 5. And I have an I3, which is positive 3. And then I have a 10, which is 10. Again, that's why I arranged it, just to make it easy. 1, 2, 3. And then put that in the calculator. X is 9.35, Y is 2.25, Z is 7.09. Now, would that make sense? Perhaps. Let's see. We have 9.35 coming to the right. And then going down, we've realized that it is coming down, which is going to be my Y, which is 2.25. And then going out over here to the right, we actually have 7.09. If I apply the Kirchhoffs current law, I will have I2 plus I3 should equal to this I1. And that makes sense, yes. 7 plus 7.09 plus 2.25, it roughly adds up to 9.35. So this is correct. I in equals I out. And the direction also makes sense. This battery is stronger than this battery, so he will push the electrons down. This one's trying to push them up, but not doing a very good job because he's got less energy. So overall, we will have a flow of electrons actually coming down this way in the direction that we predicted already. So that was working out quite nicely. So, in which case is it better to use KCL? The best case is if there are 2 or more batteries. 2 or more batteries. And what would it mean if the calculated current was negative? It means the current is going in the opposite direction. Forgive my atrocious handwriting. So, final example in this case. Look at this. We have 2 batteries. We will use Kirchhoffs laws, and we will have to figure out the current flowing through each resistor. So we can go ahead and start solving. Step 1, we will find the Kirchhoffs current law. I in equals I out. If I draw my 2 loops, I can see that the current will be coming up and along this way, I1, and along this way, I2. Coming down will be I3, because both of them are going in the same direction. I have my pluses and my minuses already in order, so I've written the pluses and minuses. And then I can go ahead and find the first equation. I can say I1 plus I2 minus I3 equals 0. Okay, because I've moved that to the side. Second equation I can do, I will use the first loop, 10, which is the battery, minus whatever this one was, R1 times I1, which is 10 I1, minus 40 I3. This, rearrange to put the number on one side, so I'll take these to the other side. This will become plus positive 10I, positive 40I, and then equals to 10. So I've already flipped the side as well, so I will have it looking like this. Third equation is exactly the same, very easy. Follow the loop around, plus 20 minus this I, and again, remember this was I, which I was this? This is I2, I've written it here. This is I2 times 20 minus 40 times I3. I have it written now. Rearranging a little, I will have my 20, I'll put it away to the other side. This will be 20I2, 40I3 equals 20. I skipped the step, and I hope you're following that. All I did was I made this positive on the other side, made this positive on the other side, and then I just swapped both sides around, just to have the letters on one side and the number on the other. That's all I did. 3 equations, plug that into our calculator. Remember, press mode, press equation, and press xyz equals n, and you will get the first equation, I1 plus I2 minus I3, 1, which is here, plus positive 1 here, minus, so it's negative 1 here, equals 0. Next one, you will do 10, 0, 40, 10, because that's I1, 0 because there is no I2, 40 because it's I3, equals 10, equals 10. Third equation, we don't have an I1 here, so I will write 0. I have I2, I have I3, and I have 20. So I will put that in, and I will get my answer, I1, I2, and I3, like this. I1, I2, and I3. I realized that I1 was actually negative. I1 was negative, so now using the blue arrow, I wrote 0.14 was actually going to the left. We predicted it going to the right. We were wrong. The current is actually going to the left instead. You could probably figure that out yourself if you realize that this battery is stronger than this battery, so this battery will be pushing the current down this way into the junction and down as well, but it will also push some back this way as well. There will be some back current because he is stronger. So it's not entirely important. Just remember, minus means current is in the opposite direction. Okay, there are a couple of things we need to know on the Wheatstone bridge as well. This is only for grade 12 advanced. I'm going to quickly show you. If I have a potential divider, we know how to solve using the potential divider. I can have a second potential divider, which means I can technically combine the two potential dividers, and I can calculate the resistor of each one. This is something that's really useful in, for example, light-dependent resistors, or if you have a temperature-dependent, like a thermostat, it can change the temperature for you. You can choose to switch the AC on or off whenever you like. That's the whole point on a Wheatstone bridge. So you have two potential dividers, and it can help you actually calculate the value of the unknown resistor. There is a way to derive it. I'm not going to go through the derivation here. It is self-explanatory in the video, so you can, not the video, the PowerPoint, you can follow it through. What you do need to know is the final formula, which will simply be R1 over R2 equals R3 over R4. R1 and R3 should be equal anyway because they are in parallel. R2 and R4 should be equal. They are in parallel, considering that the voltages we're talking about. So this is the rule. R1 over R2 equals R3 over R4, and then you can go ahead and solve for anything. I'll make this a little bit bigger there. So if I have 2 volts coming from the battery, very nice, but if I wanted to find X, so all I need to do is just put the numbers in. R1 over R2, R3 over R4, cross multiply, get your answers.